Thank you for joining us today to another Central Innovation webinar. I'm your host, Nando Mogollon. And today we will be starting the last module of the series. This module will be dedicated to IFC Special Use Cases. Now, with Special IFC Use Cases, we actually refer to the cases in which you're going to use IFC files other than coordination for project information models and deliverable asset information models. So we will take a look at design handovers and as an extension of that to round trips, which is something very specific and very particular in this case, and we'll make some notes on that. But in the future webinars, we will be also looking at sequencing and construction simulation, not the actual sequencing, but the way in which you will expect to export a file or exchange an IFC file as if it was produced with Archicad for the purpose of sequencing and construction simulation. Same thing for quantities and costing. Structural analysis, which has a particular new feature in Archicad 24. And asset management handover when you finish the project. Now, just as a reminder, if you have missed any of the previous webinars, you can catch up by logging into myCI at centralinnovation.com and get up to speed with all the previous webinars of the series. As always, please let us know if you have any questions or suggestions by typing those in the question panel on the GoToMeeting or the GoToWebinar, and we will do our best to address those either at the end or right away if it's relevant to what we're presenting. Now, without any further delay, let's start with the objectives of today. So today we will be covering the following points. We want to take a look at the concepts behind design handover when you're using IFCs for such a purpose, because as you may recall, handover, it's better done in different ways rather than using exchange format as IFC, but it can be done. And within that, we want to review some of the concepts that will clarify why are we going to do what we're going to do in the next step, where we're going to use calibration files within a calibration process using Archicad. And we will make a note on if there's any requirement to ask for modifications to whoever created that file. We'll say, hey, this is the kind of things that they may need to change given the receiving file. All right, now getting into the topic itself. The objective of this IFC file that we're going to use today, unlike the typical exchange for coordination, where you essentially exchange a file that you don't know or you're not 100% sure which software will be the receiving software. In that case, that IFC file needs to be set up in a way that can be interpreted by different pieces of software using the standard format and the standard schema within the IFC. Now, within the context of a design handover, this changes a bit, because now you actually do have knowledge over which software will be communicating with which other software. And that could be Revit, which is very popular and it's very common nowadays, but it could also be something like Vectorworks or Allplan or any of the other authoring tools out there. Now, the key difference, again, is that the IFC that will be doing the exchange can be and should be calibrated so the translation between the two pieces of software is optimized. When we talk about optimization of these files, we want to pay special attention to geometry. Geometry in this case is critical because in most cases, the design handover is based essentially on the geometry that is coming through. Now, this is not to dismiss data attached to it. It's just to say that in most cases, the most typical thing is that you want to have the geometry as it is and as usable as possible. So geometry, it is critical. Now, there are two ways for computer software and for IFC and all BIM certified software, in a sense, to read and write geometry. In essence, just to understand geometry. And there are essentially two ways. There is explicit geometry, and that is the typical case for boundary representations, but also a triangulated surface like a mesh. In that case, the computer will actually be describing every individual point, corner, edge, and face of the geometry in order to build a volume or a solid. On the other side, you have something called implicit geometry. This implicit geometry is the kind that follows certain rules in order to recreate some sort of a geometry when it reads from the code back to your three-dimensional interface. A good example of this will be extrusions, sweeps, and rotations around an axis, but it can also include CSG or constructive solid geometry, as in Boolean operations when you have basic shapes or primitives, as they are called, and then based on subtractions and additions, you will be able to reconstruct some type of geometry. Now, in the case of Archicad and Revit or Allplan or Vectorworks or EcoSim or the other, this implicit geometry is very common because it is based on the productive tools that you use. Think of it as typical walls or beams. They're good examples of extrusions along a vector, but also planar things like slabs or roofs. Now, explicit geometry also has a role in those pieces of software, and you can think of that inside Archicad for the morph tool and the mesh tool as being good examples. Some objects inside Archicad use the explicit geometry method to begin with, but it actually depends on the object, since, in the GDL scripting code, you can actually describe explicit or implicit geometry. Now, when it comes to the exchange, you will actually prefer, in this particular case, to go for implicit geometry, which is then going to be able to be reused inside the software. Now, before we start with the actual exercise, I want to clarify a couple of things just to make sure that we're on the same page. A handover relates to any situation where one designer will be passing the ownership of the model to another designer. So the second designer will then carry on the development of the model until completion. A round trip, on the other side, which is something we announced, it's in this context will be just a temporary change of ownership. In this case, the model gets sent from one designer to the other for review or modifications, and it's supposed to be sent back to the first designer with some changes. Now, round tripping, or this way of sending one model around and then send it back, it is not advisable, it is not recommended, and it's far from a good idea when using IFCs, because you actually want to use the native software. Otherwise, there's going to be far too much changes that will need to be done to the file just to revert it back to its initial stage. So it is not recommended, but some of the principles that we're going to mention here may apply to that if you're actually forced to do it. Okay, so just to be clear, we're not actually endorsing round tripping with IFC, but we recognize that eventually you may find yourself in a situation when that needs to be done. So some of the principles here will help you in the process of doing that. Then there's actually another concept that we're going to talk about in a future webinar, which is just same discipline collaboration, just using different software. Imagine a firm doing the core and interiors of a building while the other one is doing the envelope, or a base building IFC coming from IFC from an architectural firm given to an interior design firm. That's a whole different thing, and we'll talk about that in our next webinar. All right, so let me jump back here. And what we have right there will be just an empty file in Archicad which I'm going to use for the purpose of receiving a particular file that you're familiar with, because we talked about that in the beginning, which is a calibration file. Now, in this particular case, we're not going to use a calibration file for the location of the project or the setting up of stories and rotation. We're going to use a calibration file to make sure that the translation is correct for the sake of reusing the file and carry on with the design. In that case, we need to make sure that the translation that happens inside Archicad will build IFC Geometry in a way that can be reconstructed by the receiving software with the native tools, because that's going to be the only way you can then carry on a design. Otherwise, you're going to have to rebuild things, and you want to minimize the amount of those items. Now, in that way, then you can use that concept of implicit geometry, because then you actually want to have walls as walls, columns as columns, beams as beams, slabs as slabs, etc., etc., etc. There are some limitations for that, and we're going to look at those limitations just as well. Now, the next thing that we're going to ask for is for the other party to create what is called a calibration file. Now, I have a snapshot here. I'm going to give you a brief example of what a calibration file will be. And in our case, we actually just, let me see, this is a little bit blurred because far screenshot, but it will do the job for now. In that file, what you want to have is a series of sample elements of each type that you think will be used in the project or that actually have been used in the project. This is prior to sending back and forth the actual project file. You can imagine that with a file this size, translation and calibration will take you far less time than actually jumping right ahead and doing tests with a large file or a complex file. And it will give you an idea of where potential changes needs to be done before you exchange the final file. So what we have in there is a series of elements. You want to divide that into basic elements like walls, slabs, and roofs. Then you go for columns and beams. And then you go for complex elements like curtain walls, stairs and railings, objects or components, if it was in Revit, and spaces or zones, if it was Archicad. Now, that will look something like that. You want to make sure that you sort of understand what is it that you're going to receive. And again, the whole purpose of this will be a handover. So we have asked the Revit side to exchange with us an IFC model in schema 4, that is IFC 4, with the model view definition, or MVD, for design transfer. Now, there's no magic to the design transfer. Most of what it does is try to recreate all of this geometry as possible with implicit geometry methods. So instead of using boundary representations, it will try to use extrusions and solid operations. So let's take a look at that first, as we always do in an IFC Viewer. So I'm going to go ahead and take a look at that here in Solibri. Now that I have it in there, you can take a look of what is it that they have produced. Make sure that everything is in place. In case you're using a regular or neutral IFC Viewer, in most cases, spaces and zones will be hidden. So I'm just going to switch that on just to make sure that it is there, so there I can find it. And then once you have it here, the two things you will be looking for to sort of validate the file before you bring it into Archicad will be essentially two things. You want to look inside this file for boundary representation elements. And within, it depends on which software you're using for the validation, but most of them will allow you to check for things on a model tree or a hierarchy, or you have a searching method like in Solibri. So I'm just going to type up here, boundary, and that is likely to give me or to filter all the elements that have been produced with boundary representation geometry. And as you can tell, some of the ones that I was expecting, like the stairs and the railings, if I click on those, you'll see that down here, let's check the composition of that. That's there. And you check geometry, it actually says boundary representation, meaning that it's composed by every single corner and face and edge rather than a rule-based geometry. So I know based on that IFC geometry there that regardless of what I do inside Archicad, those elements will never come up as either stairs or railings, just because the producing software, in that case that was a Revit file, didn't produce that geometry based on implicit geometry. It created explicit geometry. So those are likely to come through either as objects or morphs, depending on what I've chosen in my translator. Same thing will happen with this little object here, which is actually a desk. So that had been a component inside Revit, and again, same thing, it's been created with a boundary representation. All right, then there are some windows there that I can tell. And let me set this back. Most of the other elements are supposed to be ruled representations. So let's take a look at a special case with the curtain wall. Now the curtain wall itself will be divided into sub-elements. So it will actually decompose into individual bits and pieces, frames and panels in most cases. And those are actually built on extrusions. So you can tell then how that frame is actually an extrusion, which means it's an explicit geometry as it is in IFC. Same thing will happen with the panels. Panels themselves those panels, if you check out in here, they'll be done with extrusions. But because of the way they're put together and because of the difference in software, you'll find that those may or may not come as a native Archicad curtain wall. So let's go and check this file. I'm going to start receiving this file on Archicad. So what I want to do is just going to jump back here to Archicad. What I have is essentially an empty file. That empty file, because of time restrictions, I've already started creating a dedicated translator for the calibration. So this is the process of calibrating the translator for incoming files, actually. So I'm going to go to the IFC translators. And I've named this 1234 since that was the project number that I was using in my fake project. And out of the translator presets, there are 3 of them that are critical for the geometry to come through in a way that you can reuse it. First one will be geometry conversion. Let's go and take a look. And for this, I actually want to force, as much as I can, Archicad to build construction elements, that is, trying to match these native tools. And then for those objects that cannot be made with the native tools, I want them to create morphs. Same thing will be for MAP elements and any other additional elements that might be on the file. I'll use the IFC site location, again, as it is recommended. And since it is supposed to be creating extrusions and so on, I want Archicad to create profiles out of those so that I can go and check them and see if I can reuse them or fix them. So that will be the geometry conversion. Then let's take a look at the layer conversion. Once again, we are receiving a file with a number of layers, and we want to match those layers to our own file because we're going to carry on with the design. Again, taking a look back here in Solibri, if I select the option to show me that file within the layer list, these are the layers that I will be expecting. So it is actually up to me if I want to go and take a review of those down here and say, okay, show me what is on the columns, show me what's on the generic models. That seems to me just the text. Glazing, all going to be those windows there, walls, and so on. So it seems to be pretty straightforward. So I can do a mapping for those back in Archicad. So I'm going to go back here, go to the layer conversion. And what I've done, which is something that I haven't completed, just to show you how it gets done, is that I've created a preset for that, where I actually want to use existing Archicad layers, but not to drop everything into a single layer. I actually want to do a mapping. And the only reason for that is because, once again, I want to reuse the file and I'm familiar with my layers, not with their layers. So from here, all you need to do is to merge the calibration file. That's just going to merge the layer list. There you go. It's going to tell you, look, can't find those layers in my files. You're going to have to match these with something. So this will be a process where you go, areas should go for zone rooms. Oh. Let's go with the other one. Columns should go for columns, say exteriors. Floors should go for slabs. Let's do slabs as well. Generic models, not sure what those will be, so I'm going to drop that into morphs general or similar. Glazing, Archicad doesn't really use a specific layer for windows, so I'm just going to use the walls for that. The curtain wall should be a curtain wall. Same thing here. All right, let's speed this up. Furniture should be and beams. Columns again. And this seems to be like a generic structure there, so I'm just going to move it to structural framing. So something like that. You get the idea. Your list might be a much larger list, but that's exactly what I want to do. Let's click on OK. That's the one that's going to be used. And now, for the sake of appearance, but that's also going to be controlling the cover and cut fields. That will be reflecting on your actually plan and section representation of your file. So you want to go and do the same thing, do a matching, which you can tell I've done already, pretty much the same way. You just load the incoming files by merging from IFC. You're going to get a list of materials as they were defined by Revit into the IFC. I'm going to map that back to Archicad by simply doing a matching, same way, same process that I did just now with the layer list. Okay, so I've got that. Oh, by the way, let me note something additional here. There's an option down here, too small for what it does, that can override the material, the surface material associated with the building material inside Archicad, based on whatever color was assigned to the IFC element. Now, that will create additional surface attributes inside your file, and you may need that or may not. That really depends on if the original file had overrides or no. I tend to begin without it and see how far can I go without that override, and then only on demand I will change that. I'm going to go with OK. I'm going to try this file for the first time just using those settings. Now, the next thing that I'll do, since it is a calibration process, is I'm not going to merge the IFC. I'm actually going to link in the IFC so that I can keep doing adjustments for noting back to the original creator of this file that we need some fixes here and there. So all I need to do is make sure you're on the ground floor. This is a simple file with only one story, so there's no need for me to set up anything different. Note that I'm not using the survey point as I want to receive the file as it is. So the only thing that I'll do now will be simply to go and place a hotlink. Select the IFC file to be my hotlink. IFC calibration file. Make sure you're using the actual translator that I've just created. 1, 2, 3, 4, Design Handover. That's a 1. Select that file and place the hotlink. From within here, you can actually choose to filter out things if you don't want to deal with them right away. In this particular case, for the exercise, I'm going to show everything. And now I can see in the preview that the file has created most of the elements that I was expecting. So I'm just going to click on the outside to complete the action. Now I can go ahead and take a look at what has been created out of this file. So I can see there are a list of walls and floors down there. And if I compare these with the list that I've got here, okay, let me take a look at this. Okay, the first thing that I'm noticing is that there's a floor missing down there. So I'm going to take a look at that, probably in 3D, to make sure that I can see everything. Well, actually, it is there in 3D. I'm going to see why that was the case. Everything else seems to be okay, but I want to show you what okay means. Now, let's start with these basic walls. I'm going to go through these a little bit faster since this is taking a bit of time. Now, note that these are actual native walls using native attributes. In this particular case, they're actually using composites for it rather than using just an explicit geometry. It's also being classified correctly due to the native classification. And if I just try to create or recreate a wall like that, I can see that these elements are sort of displaying correctly as much as they had been designed. Also note, there are no surface overrides because I've chosen the software not to give me those software overrides. And since this is the way it was built in Revit, the construction line is centered on the wall rather than the typical Archicad behavior, which tends to be going to one of the sides. Now that you can't change that because that's the native setup of the file, but you can, if you want to reuse that type but not drawing in that particular case, you just need to reset that to, let me show you here, to whatever offset needs to be reset, which in this case might be just go 0 to 1 face, or the core face, or the center. That's personal preference or project standards, and then they will be changed. If you do that to the incoming file, mind that the wall will move because the reference line will stay put, unless you do a bunch of other editings, but essentially you want to be careful with that. So that was the case for a single simple wall, like so. Let me show you here in 3D. So that was the case for a simple wall, a composite wall, but also what Archicad will do as a complex profile. In this particular case, Archicad actually creates two walls stacked on top of each other, but keeps the geometry as it was, making sure that all of these are native elements. Now, what happens when you have the same wall but with a different shape? So in that case, you don't have a rectangular wall. In that case, Archicad will be smart enough to trim or crop that view. So this is still a wall, as you can tell there, and there's no need for Archicad to create a VREP based on that. Now, If I multiply that on the side, well, I won't be able to do that, but I'll, okay, let's do that the next time. Same thing will be for these elements like doors and windows. They will be created as proper objects as long as the shape itself and some of the other parameters might be able to be represented, and they will belong and be related to the walls themselves. Now, note that because of the option we've chosen with the building materials, this particular object doesn't come with a proper glass color or a frame color, even though you can see here in the IFC file, let's zoom in a little bit, that those doors and windows do have a glazing and a different framing color. That's just because we have explicitly chosen not to bring in the overrides. So that's a reason for that. Let's take a look at this, where now we have an interface between those elements and these elements. Note the following: because we have created a match in the building materials, now Archicad's priority connections between building materials will take precedence. So these are still going to be walls, not B-reps. And depending on the building material priorities, either one or the other will be cut. In this particular case, seems to be that one of the walls building materials is stronger than this concrete. Therefore, they will be cut. But that is essentially a change given the translation. And then this one here, which is actually, if you go and take a look at the IFC, I know that was created with the Revit floor tool. Let me show you. And it's creating just a regular floor. The only difference, which is a very common thing, the only difference is that this one here, it's actually a slab with a slope to the center. So in that particular case, that'll be decomposed into 4 different slabs, all of them sloping to the center for a drainage point, let's say. Now, even though that was created with a slab tool and it's recognized by IFC to be a slab, Archicad's limitation with the tools will tell you that, well, can't really build that with the slab tool because slabs don't have a slope inside Archicad. So what it does, it will try to recreate that with the next available tool, which in our case will be the roof tool. But note the following, which is a pretty smart thing to do for Archicad. It will create that with the roof tool, but it will actually understand it and classify that as a slab, as it should be, right? So you get actually the individual slab just built out of the different parts. So that's how that will be translated, but that will be better than a simple B-rep like a morph and so on. Same principle will apply to columns and beams. Note that they actually come through with their actual profiles, so you can carry on, modify those, and then those modifications will be reflected into the item. And the example, well, let me go back here. Rooms, they won't be visible because that's how I have it, unless I change that. By doing so, then that will be a proper Archicad zone. The color is just the representation of that. This element will be a complete morph. We noticed that already inside the IFC, and the same thing will happen with the railings and the stairs. Note that they are actually built with morphs, even though they are classified correctly. So the classification is the one that you want to follow, and you will notice that they are actually right. And the last bit that we want to take a look at will be the curtain wall. Now, this curtain wall, because of the differences in the 2 pieces of software, Even though the IFC was an extrusion, Archicad doesn't understand that as to be a proper extrusion, and instead it will build the explicit geometry out of that. So that's based on due limitations on every different package. So the case for that will be then, if I cannot reuse it, at least I can measure it. So if I have it there, you should be able to measure that, check the frame size, the distance in between frames, and you should be able to recreate that, since now it will be very difficult for you to simply handle that and stretch it and get more frames. So recommended solution there will be just build your own, which you'll be able to do something. Actually, may do it this way. These I had pre-cooked, as you can imagine, but you can actually pre-build your own, which should be looking pretty much the same. But at least you have a good starting point. So rebuilding those are not that difficult when in need. Now, if there are any comments from this file that I should be sending back, there could be. Now, the way you want to collect those will be initially by selecting which kind of geometry you want to make a change of. That could be the covering or surface finishes for them. Maybe this particular wall was supposed to have a painting in front of that CMU, but that didn't came through. So those are kind of things that you want to double check and make sure that they are affecting your file. Otherwise, just go for surface overrides. On the other side, for things that may require a particular profile, that will be the case of certain columns that have with simple sizes but no profiles. That's another one that you may want to request and say, hey, can you send me these specific profile settings, because I need to apply it to these particular element types based on the ID or some other identification method. And then lastly will be the fact where the situation where you may to start requiring for certain elements to be split into sub-elements. That will be the case of stairs and railings. In case you say, look, I would rather have those as a different element type, this one is coming right through as the right thing. But if you want to have those as an object, you may need to create some changes in the file. In this particular case, most of the things have been coming through just right. So they're little, simple elements. And those are the ones you want to fix to begin with, so that now that we will receive the actual project file, you know that most walls will behave correctly. You know that some or most of the stairs and railings and curtain walls you probably will need to modify. And you know that most or every single individual component for joinery and loose elements, they will need to be converted to something else. If that is the case, what I will suggest is to bring those back in, not as a morph, but as an object, and you can get them as a library part in your file. Otherwise, if you want to create and modify those, you can always use that simple trick of making a copy of that, because the copy you can actually edit, modify the finishes. There's no mystery in that. Just do that quickly here. Say something like that just to give you an idea. And then you can save that as a proper object if you want to reuse those. Otherwise, just use your own and do a replacement. Before we go, a few notes. We have only taken a look at calibrating an incoming file, which is what I just did there, but not a lot more. In the next webinar, we would like to use this calibration that I just did there with a few changes to bring in a sample file from Revit, something that looks more like a project, and we will see how successful the calibration was. Okay, so I hope you found today's webinar useful. If you want to stay up to speed with all of our IFC collaboration webinars, please subscribe to that link on the screen. Otherwise, just use the QR code there, which is going to take you to the same website, I believe, where you can also subscribe to any incoming webinars. In the next part of the webinars, we'll be looking at the other special use cases, and you'll see how that works on that side. I hope I can bring in the future some special guests for all of those different use cases, sequencing, quantity takeoffs, and so on. As usual, get support here in Australia and New Zealand by using that website on the screen, myci@decentralinnovation.com, or the emails, or calling the support hotline. Stay tuned for next Tuesday and around the same time, and we will be running another webinar of the series. Please check all the content we have on myci@decentralinnovation.com, and we'll see you next week. Thank you very much, and till then.